This is section 8.2, Exponent Properties involving quotients. So, if we have, for example, 7 to the 6th over 7 squared, I want to think about what's going to happen. So, 7 to the 6 means that I have 6 sevens on top, and 7 squared means I have 2 on the bottom. So what's actually going to happen is 2 of those are going to cancel, and I'm just left with 7 to the 4th. And if that's a little bit confusing, think about when you do 8 divided by 4, you get 2. But think about what's actually happening. 8 can be broken down into 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. And 4 is 2 times 2. Well, you're left with 2, just like you did over here when you divided. So 7 to the 6 over 7 squared leaves you with 7 to the 4th. And if you remember in our product property, when we multiplied powers, we added exponents. So now when we divide, we are going to subtract. So it's actually becomes 7 to the 6 minus 2, which is equal to 7 to the 4th. And this is our quotient of powers property. So to divide powers having the same base, subtract exponents. So if we have a to the m over a to the n, that's the same as a to the m minus n, where a is not equal to 0. So for example, if we have 4 to the 7th divided by 4 squared, that's 4 to the 7 minus 2, which is 4 to the 5th power. And again, they have to have the same base. Alright, here are some examples. If we have 8 to the 10th over 8 to the 4th, 10 minus 4 is 6, so that's 8 to the 6th power. And then we have negative 3 to the 9th over negative 3 to the 3rd, and because that's the same base, we just subtract. 9 minus 3 is 6, so we get negative 3 to the 6th power. Alright, so we have 5 to the 4th times 5 to the 8th over 5 to the 7th. So we have to remember our product property, and on the top we're going to add exponents. So we end up with 5 to the 12th over 5 to the 7th, and then 12 minus 7 is 5, so 5 to the 5th power. And this last example, 1 over x to the 4th times x to the 6th. Well, to multiply we just go across, so we end up with x to the 6th over x to the 4th. 6 minus 4 is 2, so we get x squared. Alright, so the other property we have for quotients is the power of a quotient. So for example, if you have a over b raised to the 4th power, think about that's just a over b 4 times. So a over b times a over b times a over b times a over b. And then you just end up with a times a times a times a on the top, and b times b times b times b on the bottom. So that's a to the 4th over b to the 4th. So that leads us to our power of a quotient property. To find a power of a quotient, find the power of the numerator and the power of the denominator and divide. So a over b to the m is equal to a to the m over b to the m, where b is not equal to 0. Or for example, 3 over 2 to the 7th power becomes 3 to the 7th over 2 to the 7th. So for example, we have x over y cubed, which becomes x cubed over y cubed. Then over here we have negative 7 over x squared, and that becomes negative 7 squared over x squared. And remember, that negative could go with either one, but it doesn't go with both, because if it were negative over a negative, then the whole thing would be positive. So that becomes negative 7 times negative 7 is a positive 49, over x squared. And here's one more example, kind of putting everything together. So we have 4x squared over 5y raised to the third power. First thing we have to do is look at the top and distribute that 3 to the 4 and the x squared. So you end up with 4 cubed. X squared raised to the third becomes x to the sixth over 5 cubed y cubed. So don't forget that it has to go to both on each part. So see, these are some of the more tricky ones. Well, 4 cubed is 64, x to the sixth, and 5 cubed is 125, y to the third. And then for b, a squared over b to the fifth power becomes a to the 10th over b to the fifth times 1 over 2a squared. And then we end up with a to the 10th over b to the 5th 2a squared. A to the 10th over a squared is a quotient that we're going to subtract, so we end up with a to the 8th on the top over 2b to the 5th. And don't forget, even though I had b to the 5th times 2 on the bottom, because multiplication is commutative, I can switch that. And that would be it for this